Okay, can everyone see my screen?
Yeah.
Ma'am.
Yes.
Okay, so first we're going to start off with a little bit about what this program entails. So we're going to be conducting science sessions through Zoom twice every month, and these will entail a presentation about the STEM field, a Kahoot or another fun quiz to follow, and a guest speaker in the STEM field. This time we have Dr. Cran Lucas, and a fun interactive activity. And the goal at the end of this is that the students who participate in the program will take what they have learned through the STEM sessions and apply it to a scientific experiment, which can then be presented through a science fair that will be sponsored by SciPort and the STEM Alliance. And the top prize winners will possibly be able to be sponsored to participate in the Region 1 Science and Engineering Fair. Okay, so let's talk a little bit about the scientific method. So the scientific method, you first ask a question about something that you're interested in. So whether it's, if your shoes are smelling, why are my shoes smelling? Or why is this plant growing? Or how can I make this plant grow faster? Or any question that you have. And then you do some research on that, some background research about what has been done in the past. You formulate a hypothesis. Then you actually conduct your experiment. And from that, you can analyze your results and then get to a conclusion. And then, of course, you can win the science fair. So our first session is going to be on astronomy, and our topic is our universe from big to small. So what is the universe? So our universe is basically everything. It's you, it's me, it's our planet, the stars in the night sky, and much, much more. But you may ask, if our universe consists of everything, then how big is our universe? Well, a very long time ago, we thought our universe was just the size of our Earth, which is pretty small in comparison to the size that we know of our universe to be today. So you can see comparison right here. Now, when your great-grandparents were in school, we thought that the universe was only the size of 1/2 of our galaxy. But today, we have discovered through technology that our universe is much bigger than we could have ever imagined. So think of the biggest thing you can think of and multiply the size of that by 1 billion, and you'll get the size of our universe. So now that you guys have an idea of what our universe is and how big it is, let's all hop on board the spaceship and see some of the coolest sights that our universe has to offer. So first, we're going to stop at a couple of galaxies. So there are tons of galaxies in our universe. Some galaxies are very small with only a few million stars, and others have as many as 500 billion stars. And there are 3 types of galaxies: spiral, elliptical, and irregular. And galaxies are just a combination of tons of stars, dust, gas, and other types of matter. So one of the most beautiful types of galaxies are spiral galaxies, and they're a collection of stars and gas, and they're made up of very hot young stars. And you can see a picture of a galaxy right here that I actually took. Elliptical galaxies are the most abundant type of galaxies found in our universe, and they lack the beautiful swirling arms of spiral galaxies, but they're still very cool, and they are the less well-known of the galaxy siblings. Then you also have irregular galaxies, and they don't have an identifiable shape or a structure to them. So they just kind of look like a big blob in the sky. So they don't look like an elliptical shape, or they don't look like they have spiral arms. So let's see if we can identify some galaxies. So if one of the kids can respond, what kind of galaxy do you think this is? And the options are elliptical, spiral, and irregular. Let's see, Ruby, do you know what type of galaxy this is?
I think irregular.
Good guess. Let's see, does anyone else have an idea of what kind of galaxy this is? What about Kaden?
I don't know.
All right, well, let's see, what does it look like? It kind of looks like an oval, right?
Mm-hmm.
So what were the 3 options? We have elliptical, we have spiral, and we have irregular. So elliptical looks like an oval, Spiral has spiral
It's
arms.
elliptical.
It's elliptical. Correct. Awesome. What do you think this type of galaxy is?
Irregular.
That's correct. Wow. Okay, anyone else? What do you think this type of galaxy is?
I know it's this. I forgot the name of it.
It looks like it has spirals. So what type of galaxy has spirals?
I don't remember the name.
A spiral galaxy.
Ah.
Yes. And what about this one? This one's a trick question because it looks like it's an oval shape. But if you look at it front on, you might actually be able to see something else. What type of galaxy do you think this is? Ruby, do you know?
Maybe spiral?
Yes, that's correct. That is a spiral galaxy. And this galaxy is actually really cool. It's known as the Andromeda Galaxy, and it's our neighbor galaxy. So just like we have neighbors in our own neighborhood, this is the closest galaxy that's to the current galaxy that we're in. All right, so our next stop is actually going to be our own galaxy. And our own galaxy is called the Milky Way Galaxy. And we don't have to travel very far to the Milky Way Galaxy because that's where we're in right now. It is 13.6 billion years old. So that's really, really old. Much older than you and I. Super, super old. And when you look at the Milky Way Galaxy, you can't really ever see the entire thing because we're inside of it. So all you really see is a milky band of light. So if it's a really, really dark night, you might actually be able to see something that looks like this that you can see in the background of the slide. It has over 200 billion stars, and our sun is only one of those stars. And we actually can't even see we can actually only see 10% of our galaxy because the other 90% is matter that's invisible. So we can't see 90% of our own galaxy. Another cool fact about the Milky Way Galaxy is that it may actually have been made from other galaxies that match together. So that's super cool, right? And another cool fact about our Milky Way Galaxy is that we can't even take pictures of it. So we don't really know what our galaxy looks like because we're inside of it. So our next stop are going to be nebulas. Have you guys ever heard of nebulas before? No? Okay, so a nebula. What did you say, Kaden?
They're kind of like a star?
Yes, kind of. That's correct. So nebulas are actually where stars and planets are formed. They're star nurseries. So you were very close with that definition. They're a giant cloud of dust and gas in outer space. And here's a picture of one that you can see right here. And they're very, very pretty. So one of the coolest types of nebulas, to me at least, are supernova remnants. So supernova happens when a really, really old star dies and it actually explodes. And this is a super, super powerful explosion. Something really cool about supernovas is that if there were no supernovas, we wouldn't actually be here today. Because supernovas, when they explode, they have these really, really awesome elements in them. And these elements then dissipate throughout the entire universe. And that's the reason that we find elements on Earth. So can you guys name any elements that you know of? So like hydrogen is an element and iron is an element. Do you guys know any other elements? Ruby?
I don't know anything.
I'm sure you do. Okay, Kaden, what's an element?
Helium?
Helium is an element, correct. That's awesome. What about carbon? Is carbon an element?
Probably.
Yes, carbon is an element. Yeah, you know that pencil that you have, that you write with in school? The lead of that pencil is made from carbon.
Ah.
That's super cool, right?
So that.
And it's that carbon that came from the explosion of a supernova. So that's super cool. So our next stop is our coolest stop on this trip, and there's stars. And stars are the most abundant things in our universe. So when you look into the night sky, you see so many stars, and they're all super far away, which is why they look like little tiny dots. Some stars are actually 200 times larger than our own sun, yet they look so small because they're so far away. And other stars are even smaller than the Earth. Stars are huge balls of gas just held together by gravity. And the central core of a star is super, super hot, and they produce so much energy, which is why we actually see that energy as visible light. And that's why we can see those white dots in the night sky. Our sun is just one star out of an estimated 100 million stars in our own Milky Way galaxy. That's a lot of stars. So here are some types of stars. So you have a red giant star, a red supergiant star, a blue giant star, a white dwarf star, a yellow dwarf star, a red dwarf star, and a brown dwarf star. And so what color do you guys think of when you think of something that's really hot? Landry, what color do you think of?
I think of like a golden color, kind of.
Golden color, yeah. What other color do you guys think of when you think of something that's super hot? Caden?
Red.
Red. I think of red too. What about you, Ruby?
Like a yellow, but
A yellow. Yep. Those are all pretty valid colors. But something that's really interesting about space is the hottest stars, they're not red, they're not gold, they're not yellow, but they're actually blue. And here on Earth, when we think of blue, we think of something that's super cold. But in the universe, blue actually means that it's really hot. So the hottest stars here are actually the blue giant stars. They're super, super hot stars. So which one of these stars do you think our sun is out of the list that's here? What about you, Landry? What do you think, which one of these stars do you think our sun is?
Maybe the yellow dwarf star, because it sets off like a kind of a yellowish skull.
Yes, actually you're correct. Our sun is actually a yellow dwarf star. So that is super impressive that you're able to guess that. Okay, so just like we have life cycles, and just, like the tadpole in a pond has a life cycle, and just like a butterfly has a life cycle, stars also have life cycles. And they're born in something that's known as a stellar nebula. So we actually talked about nebulas before. They're the birthplaces of stars. And in these nebulas, so many different types of stars can form. When a star gets really, really old and starts to die off, it actually explodes into what's known as a supernova. It can also explode into a black hole, and then it can also create a neutron star. So that leads to our next stop, and our next stop is going to be a black hole. And this is my second favorite stop on our trip. So black holes are super cool. Have you guys ever heard of a black hole before? Yes. So a black hole happens when, like I said, when a really large star runs out of fuel and it can no longer support its really heavy weight. So just like when you've been working out a lot and you're really tired and you just want to go to sleep on the bed, well, stars want to do that too. They get really tired after they have been running for a really, really long time. So then they collapse into something that's the size of an atom. So you know how big stars are. They're huge, right? And imagine them collapsing into something that's so small, so tiny that you can't even see it. But this really tiny atom actually has the same mass as that star. So it's just as heavy as a star, but it's smaller. So that means it's super, super dense. And what this means is it has a huge amount of gravity, so much gravity that you can actually get sucked in. So imagine, like I said, squishing a huge star into an atom. So that gravity is super powerful. And it's so powerful that if you go even close, super close to the black hole, you'll get pulled in and spaghettified. So you see this guy on the right? This is a guy who got a little too close to a black hole. And you see how he's stretching a little bit? Well, that's because gravity is pulling him into the black hole. So we don't want to get close to a black hole because we don't want that to happen to us. So we actually have a black hole at the center of our Milky Way galaxy, and that's what we think is holding everything together. So black holes, even though they're so small, they have so much gravity that they can hold an entire galaxy together, which I think is pretty cool. So our next stop is actually going to be our solar system. So before we go on, can anyone tell me the order of the planets in our solar system? Let's see, someone who I haven't heard from in a while. Let's see, Ruby. Do you know the order of the planets in our solar system?
I don't think so.
You don't think so? Okay, anyone else? What about you, Landry? Do you know the order of the planets in our solar system?
I remember the names, but I forgot the order.
Okay, well, just tell me the names. Which names of planets in our solar system do you know of?
Uranus, Neptune, Saturn, Earth, Mars. And then I forgot the two littler ones.
That's okay. That's awesome. Those are pretty much all of the planets in our solar system. So let's go on to the next slide and we can confirm your suspicions about what those other two planets might be. So we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. So these are the planets in our solar system. We used to have Pluto, but Pluto's no longer a planet, which is pretty sad because it's so small, but we still have these 8 main super cool planets. And all these planets revolve around our star, the sun. So let's see if you can identify the planets in our system. So we have Mercury. So this is a picture of Mercury. Mercury is the closest planet to the sun, but it's also the smallest planet. It doesn't have any moons or rings. And a really cool fact about Mercury is that your weight on Mercury would actually be 38% of your weight on Earth. So let's see, Kaden, how much do you weigh?
I do not know.
Okay, let's give an approximation. How much do you think you weigh?
I don't know.
I don't know. Ruby, how much do you think you weigh?
Nah. I don't know.
You don't know. Okay. What about Landry? Landry, how much do you think you weigh?
Around 64 pounds.
Wow, that's pretty exact, Landry. Okay, so let's take 1/3 of 64. Do you know what 64 divided by 3 is?
It would be 20-something.
It would be 20-something. So you would only weigh 20-something pounds on Mercury. Isn't that pretty cool? I think that's pretty cool. That would be pretty light. And also, one Mercury year is only 88 Earth days. So who knows how many days we have in a year on Earth?
I know.
Who knows? Who said I know?
Me.
Okay, how many days?
365.
365 days. But on Mercury, a year is only 88 days. So that year would go by pretty fast, don't you think? It's a pretty fast year. You would only have to go to school for 88 days a year. That sounds pretty nice to me. Okay, so our next planet is actually going to be Mars. We just skipped over Venus and Earth, but we'll come back to them later. So Mars is pretty cool because it's very cold there, but it's also very red, and that's due to it has a lot of iron on it. So you know, like when you leave your bike out in the rain and it gets rust, this like red rust out on it, that's what's on Mars. Mars has a ton of rusty iron on it. The Martian gravity is only 1/3 that of Earth's, and that means you could leap nearly 3 times higher on Mars. Mars has the largest dust storms in our solar system, and they can last for months, and they can cover the entire planet. And like we said, on Mercury, 1 year was only 88 days, while on Mars, 1 year is 687 days. So you would have to go to school for 687 days a year. So it's so much longer than a year on Earth. Mars actually has 2 moons, Phobos and Deimos. And just like Earth only has 1 moon, Mars has double the amount of that. So like Earth, Mars has a weather season. It has canyons and has volcanoes, but its atmosphere is super thin. So that's why we think that there may not be a lot of life on it, but we're still looking for it. It's composed primarily of carbon dioxide, and it has the tallest volcanoes that we know about in our solar system. So on Earth, we have volcanoes, and they're pretty tall, but Mars has even taller volcanoes, which is super cool. So the biggest planet in our solar system is going to be Jupiter, and it's a gas giant. So you know how you can walk on Earth because it's made of rocks? Well, Jupiter isn't made of rocks. It's actually completely made of gas, so you wouldn't be able to walk on Jupiter. And it's entirely made of gas, which means that if you were to put it in a bathtub, it would actually float. It is the first planet that was created in our solar system. It has 67 moons. And even though you can't see it, it actually has 4 rings. The Earth would fit into Jupiter more than 1,000 times, which gives you an idea of how big Jupiter is. There's also a constant storm on Jupiter. And if you look at this picture here, where do you think that storm is? Caden.
Right where the big red spot is.
Yes, that's extremely correct. That is where the storm is. It's in that big red spot. And that storm is going on all the time on Jupiter, so it never subsides. And 1 Jupiter year is 11.8 Earth years. So it's 11.8 times. Okay, the next planet that we're going to talk about is Saturn. It is the 2nd largest planet in our solar system, and its rings are actually made up of bits of ice, dust, and rock. Just like Jupiter, Saturn can float on water because it's mostly made of gas. And it's super, super windy on Saturn. Winds around the equator can be about 1,118 miles per hour. So that is super fast. It's much faster than any tornado here on Earth. Another fun fact about Saturn is that it goes around the Earth super slowly, and 1 Saturn year is 29 Earth years. So that's 365 times 29. That's a lot of days of going to school. Okay, our last stop is actually going to be back to Earth. So now that we know all about these amazing celestial objects, how do we know about them? How have scientists been able to discover them? Well, that's due to the field of science known as astronomy. And astronomers have helped us learn about the universe and continue to study the universe every single day. And it's because of them that we know about all these amazing things in our universe. Astronomy is a natural science that studies celestial objects, their origin and evolution. And many astronomers use instruments called telescopes to conduct observations of our universe. So you may have wondered throughout this presentation, how do we have these amazing images of objects that are so far away? Well, let's do things called telescopes. Have you guys ever seen a telescope before? Yes? So these are the telescopes that you may have seen. So these are pretty small telescopes, but they're still super powerful. And amateur astronomers and astronomers alike use these telescopes every single day to look into our beautiful night skies. And you can transport them anywhere. You can look at whatever you want. And many of these telescopes are used to make beautiful pictures of our moon and also of planets in our solar system. You also have much bigger telescopes like these. So these are super huge telescopes, and you can just imagine what these telescopes can see. It's with these telescopes that we've been able to take such beautiful pictures of objects in our universe. And you can see some pictures of them here. We actually have super awesome telescopes here in Shreveport at the Worley Observatory, and that is an amazing facility if you guys want to go check it out. Whenever they're reopened after the coronavirus, and they have some amazing resources there as well. You also have telescopes that look like this. So can anyone tell me what they think that these telescopes might be used for? There's no camera on it, right? You can't see any way of like taking pictures through it. So what do you think they look at? What does it look like to you? Ruby, what does this look like? Or Kaden?
It looks like a satellite.
That's correct. It does look like a satellite. It kind of looks like the dish that you have at the top of your house to get signal for your TV, right? And it has an antenna. So these are actually called radio telescopes. So just like we look at the universe through pictures, we can actually look at our universe through radio waves. So radio waves are constantly being emitted in our universe from some really cool objects. And it's from radio waves that these telescopes are able to detect it in the same way that your satellite at the top of your house gets a signal to your TV, and the same way that we're able to listen to the radio in our house. And they can detect some of the farthest radio signals in our universe. And on the left is actually the largest radio telescope ever built, and it's in China. And that's super cool, and it's super big too. And some of the goals of these radio telescopes is to detect extraterrestrial signals, and it's also just to understand more about our universe as a whole. And then you also have telescopes in space. And these telescopes are huge. Have you guys ever heard of the Hubble Space Telescope? No? Yes? Maybe? Well, this is the Hubble Space Telescope, and it's one of the coolest telescopes because it's actually in space, and it can take pictures of some of the most distant objects, and it creates such beautiful pictures. And it's super cool that we've actually been able to take a telescope into space itself and be able to get images from this telescope on Earth. So here's an image of the Hubble Space Telescope. And make sure you're remembering these names because we're going to have a short quiz after this about all these names. I know, a quiz, right? It's going to be really fun. So if you like astronomy, and if you like the presentation, you can actually be an amateur astronomer, or you can even go into the field. Some fields of astronomy and some jobs that you can get in the astronomy field, or you can be a planetarium director, like Mr. Andrews, who's on the Zoom call. He's an awesome planetarium director at SciPort. Planetarium directors are in charge of the space portions of museums and planetariums, and they are awesome with interacting with our community. You can be a meteorologist. You can study our Earth's atmosphere to forecast weather conditions. You can be an aerospace engineer to design telescopes like the Hubble Space Telescope, to design rockets, space stations, space shuttles, even astronaut suits, and you can even design missions themselves. So that's a pretty cool job. You can be an astronomer through observation through a telescope and support your observations with math and physics. Who here likes math? Raise your hand if you like math. Kind of. Well, it's not that fun right now, but when you get to apply your math to super cool astronomical observations, that's when math gets super fun. You can also be an astrophysicist and use your knowledge of physics and advanced math skills to understand the laws of our universe. You can be an astrochemist. Who knows what chemistry is? Landry, what's chemistry?
It's when people combine chemicals to make a different substance.
Yes, that's an awesome definition of chemistry. So just like we can do chemistry on Earth by mixing different substances, chemistry is constantly happening in our universe through reactions between different elements that you guys listed earlier and through reactions in stars themselves. And so astrochemists examine these chemical compositions and processes for stars, planets, comets, and other things in our interstellar media. And you also have astrobiologists, and they study the origins, early evolution, distribution, and future of life in our universe. So who knows what biology is? Kind of. Landry, what do you think biology is?
Ooh. I think it's somebody who studies animals, but I'm not 100% sure.
Yeah, it's someone who studies life. So just like we have life on Earth, we have humans, we have animals, we have insects, you have plants. Well, astrobiologists try to apply their understanding of life on Earth to maybe life in our universe and also biologically relevant species in our universe as well. So you might not completely understand what astrobiology is right now, but we're going to actually hear from an astrobiologist himself. So let's welcome Dr. Cran Lucas.
All right, greetings everybody. I'm a biologist. I have a PhD in genetics, which is the study of heredity. And I've taught biology and astrobiology and other areas of biology at LSU Shreveport for 40 years. So I've been doing this for a long time. I'm also an amateur astronomer. And so because of that, I get to dabble in astrobiology. I'm a professional biologist, but an amateur astronomer. So I really have sort of the best of both worlds. Astrobiology, as Ashini has already indicated, is the study of the origin of life. How did life come about? We haven't always been here, you know, so life had to originate on this planet. And of course, because we know that life is on Earth, we also are curious to know if life is elsewhere. Is there life on other planets in our solar system? Or is there life on planets around other stars in our galaxy or even further away? So astrobiologists come in all different flavors, okay? You can have astrobiologists that study living organisms in the laboratory. They want to know how they work, what they're composed of, what kind of molecules are involved in life. How did these molecules come about originally? So the origin of life is one area of astrobiology that we study. If we're interested in life outside of the Earth, we want to know what kinds of conditions, environmental conditions, temperatures, atmospheric compositions, you know, what does it take for life to exist elsewhere? And of course, we're interested in places like Mars, because Mars, from what we now know, used to be very Earth-like billions of years ago, you know, when the solar system was very young. Mars is very different now, though, you know. So we hope to go to Mars and find evidence, if it's there, of life from past times, okay? There's also some moons around Saturn or Jupiter that might harbor life because of the environmental conditions, okay? And then we're interested in life around other stars, okay? We now know there are thousands of other planets that circulate around other stars outside of our solar system. Some of those planets are Earth-like. And as we build bigger and better telescopes, we want to look at the atmosphere of those planets and see if those atmospheres are suitable for supporting life as we know it, okay? Two important things about life. Life as we know it is based on water, okay? We all need water. We can't survive without water, okay? Every organism, every cell is composed mostly of water, okay? The other thing is that we are built out of carbon-containing molecules. All of the amino acids in our proteins, all of the fats and lipids and DNA that contains the hereditary information that makes you and me. All of those things are based on carbon. So we think life needs water. We think life needs carbon compounds. Now we, in science, refer to carbon-based compounds as organic compounds, okay? And there's a whole area of chemistry called organic chemistry, okay? So if we're gonna look for life elsewhere, we wanna look for water and we wanna look for carbon-based compounds. And that's what we've been doing. Some of you know that there are little rovers that have gone to Mars in past years. Two of the first ones were called Spirit and Opportunity, and they found water, or where water used to exist anyway on Mars. A bigger rover called Curiosity has been there for many years now, and has found all kinds of minerals and compounds that are water-based, that were formed in water. And we have a new rover on the way to Mars called Perseverance that is going to look for past life on Mars. The surface of Mars right now is not very optimal for life as we know it, okay? But we might be able to find evidence of life that existed in the past when the environmental conditions were better, okay? Now, I have a feeling that if life originated on Mars like it did on Earth, and even though Mars has changed environmentally, it may still be there, but not on the surface. It could be down below, under the ground, because you can actually dig down thousands of feet in the Earth, and you can find bacteria, living organisms, just metabolizing away down there, doing their own thing, you know. So there could be life on Mars, but you just have to dig for it, you know. That's going to take a lot of years to get there and do that, but you know, astrobiologists search for planets. You know, they study life on Earth to better understand how life might be elsewhere in the solar system or elsewhere in the galaxy. And so it's an exciting area, you know. When I was 8 years old, I looked through my first telescope. I grew up in Dallas, Texas, and one of the neighbors in my neighborhood had a telescope. And one evening, on a nice clear night, when the moon was out, he invited all the kids on our street to come out and look through his telescope. And that's when I saw the moon for the first time through a telescope. And it was unbelievable. You know, you could see craters and valleys and, you know, smooth areas, which are basically lava flows on the moon. It really galvanized. When we say galvanized, we mean it really brings our interest to a focus, you know. And so I was so enthralled with those images that I was sort of instantly converted into being an amateur astronomer. And I've loved it ever since. But when I went to college, I decided that I wanted to major in biology, and so I became a biologist. But I get to have fun in biology as well as in astronomy, so the best of both worlds. So that's a little bit about what astrobiologists do. I teach a course in astrobiology and have a lot of fun doing it. So I hope all of you will develop an interest in science, even if you don't do it professionally. It's fun to read about it or study about it. So that's what I do.
Thank you so much, Dr. Lucas, for that amazing introduction about what astrobiology is. Who thought that was super cool? Because I thought it was super cool. That was super cool, right? So Mr. Andrews, I know that you're here too, and I know that you are a planetarium director. And I know I didn't tell you that you're going to be speaking today, but if you would just like to give us a short description about what a day in the life of a planetarium director is, because I think the kids would really enjoy it.
Sure, appreciate that. Thank you for the opportunity. You all can hear me, right? You can? Okay, good. I'm sorry, these headphones are really good noise canceling headphones, so it's like, whoa. All right. I work at SciPort, Downtown Science Center, and I am the planetarium manager there. So in the planetarium world, I get to take the research that you just heard Dr. Lucas describing, right? And other research done by other professors or collaborative work done by NASA, for example, and then take what they do and then bring it to a level where people who might not have a strong background in science can understand it. It's really interesting because sometimes there's some times we know stuff. We're like, oh, this is what we know it. And then you realize, oh, science says different. I will tell you this, is that I often have to use, or I should say compare science with Disney. Okay, that's because a lot of times there's in movies and Disney and stuff, they're like, you can do this and you can do that, and I'm like, oh, it gets a great start, but not exactly correct. So I always want to make sure to keep that scientific concept before the audience. So Dr. Lucas expressed how he gained an interest into astronomy. I would like to say the way that I did it, it's hard to tell. I am a, let me show back on my name tag, I'm a big Star Wars fan, okay? So I love Star Wars. And so when I saw Star Wars, I got hooked into the astronomy and stuff like that. So by being able to work into a planetarium, I can actually talk about astronomy and Star Wars, right? So I love that. You also get to be able to bring out or highlight things that people want a better understanding of. No, I'm not an expert like Dr. Lucas is with astrobiology, but I kind of like know a little bit about everything when it comes to astronomy. So sometimes it's like, hey, he talked about thousands of planets that we have discovered, right? Well, what is the research that goes to getting those? How do we find those planets, right? So that's something that I would kind of focus on. At my job, I'd say it's also make astronomy fun, make it exciting. I get excited about it, but I think I'm a little bit biased about it. But people that, if you just have that 1 ounce, that one inkling of why, right? Just starting off with that one question of why, then you can, hopefully I can spark that and deviate it into astronomy, because as Darth Vader said it best, right? He wants you to join the dark side. So there you go. And that's all I have.
Thank you, Mr. Andrews, for that awesome introduction about what a day in the life of a planetarium director is. And a planetarium director is such a cool job because you get to interact with the community and you get to talk about why you love astronomy so much. And I love astronomy, so I think that's super awesome. So we're going to go around really quickly, and we're going to say what your favorite fact that you learned in today's presentation was. So Kaden, what was your favorite fact that you learned in today's presentation about astronomy?
That black holes that black holes can hold galaxies together.
Yeah, that is a very cool fact. And I thought that was super cool when I learned that too. Landry, what was your favorite fact?
Basically what he just said.
Yes, black holes, I agree. Black holes are super cool. They're one of the coolest parts of space in my opinion too. Ruby, what was your favorite fact?
Learning about like the different times for like our year than other planets.
Yes, that was a very cool thing. What we learned that 1 year on Mercury is only 88 days, which is a super short amount of time. All right, anyone else who wants to tell us their favorite fact that they learned today? Well, I'll tell you mine. My favorite fact that I learned today is that a black hole is the size of an atom. I thought that was super cool. That's super small and it's so powerful, right? All right, so now we're going to play a fun game. So who has played Kahoot before? No one's played Kahoot before? Okay. Oh, yes, you have played Kahoot before. Okay, so I'm going to share my screen with our Kahoot game code. And you guys know how to log on to Kahoot. You just type in kahoot.it into whatever your device you're on right now, and then I'll give you guys the game code. So can you guys give me a thumbs up when you've done that? You just type in this game code. when you have gotten onto Kahoot. And the website is www.kahoot.it. Okay, so we're gonna go ahead and get started.
When you go to a new tab, it kind of exits you out of the meeting. And it's kind of weird.
When you go to a new tab, it exits you out of the meeting.
It just takes their screen off of the meeting screen, but you guys are still in the meeting. We can still see and hear you.
Oh, okay, I see. Okay, so the Kahoot, I think when you start playing Kahoot, it doesn't show the questions. So that's why I'm sharing my screen right now so you guys can see the questions. But I'm just, okay, if you guys can't see the questions, I'll just read out the questions. Okay? Does that sound good? Okay. So I'm gonna go ahead and start the game. So the first question is, which of the following is a type of galaxy? The red is elliptical, the blue is spherical, the yellow is rectangular, and the green is triangular. Red is elliptical, blue is spherical, yellow is rectangular, and green is triangular. And the question is, which of the following is a type of galaxy? Yay! 4 of you guys got it correct. And Caden is in the lead. The next question is, what type of galaxy is this? And the galaxy picture is one that has spirals. The red is spiral, the blue is elliptical, the yellow is irregular, and the green is spherical. The question is, what type of galaxy is this? The picture is a galaxy that has spiral arms. The red option is spiral, the blue is elliptical, the yellow is irregular, and the green is spherical.
We're in serious fucking state.
Five seconds left. 5 people got it correct. Yay! And Caden is in the lead. The question is, what galaxy are we in right now? The red is Andromeda, the blue is Tadpole, the yellow is Milky Way, and the green is Snickers. The question is, what galaxy are we in now? The red is Andromeda, the blue is Tadpole, the yellow is Milky Way, and the green is Snickers. Awesome. Everyone got it right. And Caden is still in the lead. But Ruby is catching up, and Darth Vader is in second place. Okay, the next question is, which is a cloud of dust and gas in outer space? The option choices are red is galaxy, blue is planet, yellow is star, and green is nebula. We were just on the question of which of the following is a cloud of dust and gas in outer space, and the answer was nebula. And Darth Vader is in lead, and Caden is in second place. We have Rianne in third place, and Ruby in fourth place, and Landry is in fifth place. Next question. What are stars made of? Red is hot gas, blue is rocks, yellow is only helium, and green is dust. The answer choices are red is hot gas, blue is rocks, yellow is helium, and green is dust. And the question is, what are stars made of? Red is hot gas, blue is rocks, yellow is only helium, and green is dust. And we have 15 seconds remaining on this question. And 3 people got it right. The answer was hot gas. Stars are made of hot gas. And Caden is back in the lead in first place, and Ruby is in second place. Our next question. What is the hottest type of star? Red is white dwarf. Blue is red giant. Yellow is blue giant. And green is yellow dwarf. The question is, what is the hottest type of star? Red is white dwarf. Green is red giant. Red is white dwarf. Blue is red giant. Yellow is blue giant. And green is yellow dwarf. And 4 people got it correct, and that was everyone. Everyone got it correct. The answer was blue giant. And Caden is in the lead. The next question is, what is a black hole? The answer choices are a huge star that has collapsed into an atom. Blue is a ball of gas. Yellow is a hole in space. And green is the place in space with the weakest gravity. Yes, that's correct. It was a huge star that has collapsed into an atom. Okay, what are the order of planets in our solar system? Red is Mercury, Venus, Earth, Mars, Uranus, Neptune, Jupiter, Saturn. Blue is Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Yellow is Mars, Mercury, Earth, Jupiter, Venus, Neptune, Saturn, Uranus. And green is Earth, Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune. And that is correct. It was option blue. And we are going to do one more question. And the question is, which planet has the tallest volcano in our solar system? Red is Mercury, blue is Jupiter, yellow is Earth, and green is Mars. the question is, which planet has the tallest volcano in our solar system? Red is Mercury, blue is Jupiter, yellow is Earth, and green is Mars. And the correct answer was Mars. Okay, that was our last question. And our final leaderboard is Landry is in first place, Caden is in second place, Ruby is in third place, Brianne is in fourth place, and Darth Vader is in fifth place. So that's awesome, you guys. I can tell you guys retained a lot of stuff from that PowerPoint, and you guys got most of the questions right, which is awesome. So I'm super proud of you guys. I really hope you enjoyed our Zoom STEM session today. I'm going to share my screen one more time with a Google form on it so that you guys can confirm your participation in our next STEM session and whether you guys want to conduct your own science fair project or not. So I'm going to drop the link in the chat of the Google form. Right, did everyone get that? So just make sure you save that Google form and you can fill it out later. All right, thank you guys. I'm going to take, is it okay if I take a group picture really quickly, Ms. Bonnet?
Absolutely, go ahead.
Okay. So if everyone can smile. Awesome, thank you guys so much. I really enjoyed doing this presentation today, and hopefully you guys learned something new about astronomy. And just raise your hand if you like astronomy now after this presentation. If you think it's super cool. Kind of, Landry said kind of, Kaden said yes. Well, I'm glad.
I don't like not knowing things, and there's a lot we don't know about the universe.
That is very true. That's an extremely good point to bring up. There's so much that we don't know about our universe. It is so big, but it's because of astronomy that we are learning more and more about it. So thank you guys for joining our session today, and I hope to see you guys at a future session.